here I'm going to do an example of writing a transformed quadratic function. So in this example it says, let the graph of g be a translation 3 units right and 2 units up, followed by a reflection in the y-axis of the graph of f of x equals x squared minus 5x. And we want to write a function rule for g. Okay, so the first thing to do is to look at these two translations they're giving us. They're telling us 3 units to the right and 2 units up. Okay, and these are going to be happening on the f of x function. So for instance, we're going to be taking f of x and we want to move it 3 units to the right. Well, if you recall from transformations earlier in the year, that subtracting 3 from the x is going to move me right 3. And then if I want to move the function 2 units up, I add 2 on the outside. Okay, so this is kind of acting like an H transformation. This is more of a K. Right? And then lastly, if I want to, this last step of reflecting in the y-axis of the graph, I'll do this part in the end. So this reflection in the y-axis, I'm going to save for the end. So for instance, if I apply these transformations to this equation here, f of x equals x squared minus 5x, notice that normally my input is this x here, and when x is the input, I take x squared minus 5 times x. Well, now in my transformation, I now have x minus 3 on the inside of the parentheses. It's no longer just an x. So I have to plug this part in wherever I see an x in my equation. So this equation is going to be x minus 3 squared minus 5 times x minus 3. And if you look, you'll notice that wherever there was an x, there's now an x minus 3. So there used to be an x being squared, now there's an x minus 3 being squared. There used to be a negative 5 times x, now there's a negative 5 times x minus 3. And then lastly, I need to remember that I'm trying to shift this up 2, so I need to add 2 to the end of my function. At this point, it just becomes a simplifying problem. So I'm taking x minus 3 squared. Well, anytime you square a binomial, there's kind of a shortcut for doing it quickly. You square the first term, so my x term squared is just x squared. You take twice the product of the middle, so right now if I multiply the middle, I'll get negative 3x, but I need twice that product, so negative 6x. And then I square the last term, so negative 3 squared is a positive 9. And then if I look at the second part where I have negative 5 times x minus 3, that's just distribution. You just distribute it over the top. But you got to remember to keep the negative on it. So negative 5 times x is negative 5x. And then negative 5 times a negative 3 is a positive 15. And then I still have the plus 2 off to the side. At this point, it's just combining like terms. So notice that if I look at this line here, I only have one x squared term, so I'll just leave the x squared term as it is. There's nothing to combine it with. And then if I look, I notice that I have one x term and then a second x term. So if I take negative 6x minus 5x, that's the same thing as negative 11x. And then if I take my constants, my plus 9, plus 15, and plus 2, I notice that when I add those up together, I get plus 26. Okay, so this right now is the equation I get when I take my f of x function and I shift right 3 and up 2. I now have this equation. But I'm not quite done yet because I still need to do a reflection in the y-axis. Okay? Now, to get a reflection in the y-axis, okay, what that means is I want a reflection that's going to take the points and flip it over the y-axis. So it's going to take any points over here and flip them over there. And it's going to take any points on the left-hand side and flip them to the right-hand side. Okay, the reflection's going over the y-axis. If you notice, when a point gets reflected over the y-axis, its y-coordinate doesn't change. it stays the same. Like this height it is over here will still be the height it is over here. The thing that changes though is whatever x coordinate it had, it now has the opposite x coordinate. So if it was negative, it's now going to be positive, and if it was positive, it's now going to be a negative x. Okay? So notice that anytime we reflect in the y-axis, what we're really doing is we're taking the x values that we have and we're going to take the opposite of whatever they are, because the x values change to their opposite when we reflect over the y. So the next transformation we want to do to our equation that we have is this transformation right here. We want to take the opposite of every x value. So just like before, when we plugged in x minus 3 for every x, now we're going to plug in negative x wherever we see an x. So I go up to the equation that I have worked on thus far, and I'm going to plug a negative x in for where these x's are at. So for instance, that's going to give me negative x squared minus 11 times negative x plus 26. Notice that if I square a negative, I get x squared. If I multiply negative 11 times negative x, I get a positive 11x, and then plus 26. So this final equation will be the function g of x, okay? Because back up to the top, it says let the graph of g be a translation 3 units to the right, 2 units up. We did that in step 1. And then it says followed by a reflection in the y-axis. That was that last step here. And so we're left with the function g of x equals x squared plus 11x plus 26. This will be the answer.